Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder why babies seem to pick up on the rhythm of language so quickly? Well, new research might have a fascinating answer. It turns out how babies learn to prefer certain sounds in language might be tied to something as simple as how we chunk information, like putting together puzzle pieces. So what is the big question here? Well, scientists have noticed that babies learning English right from the start tend to prefer words that have a strong, weak sound pattern. Think of words like doctor or candy. This is called a trochaic pattern. They tend to prefer these over weak, strong patterns, like in the words giraffe or police. This is called an iambic pattern. Why this preference? The researchers here wondered if it is not something babies are born with, but something they learn as they listen to language. They thought this preference might just pop out as a natural result of how babies' brains learn to chunk sounds together to make sense of the continuous stream of speech they hear. Imagine a baby hearing their parents talk. It is not like us listening to a dictionary with clear pauses between each word. It is a constant flow of sounds. For a baby to learn words, they have to figure out where one word ends and another begins. This is a really tough job. One idea is that babies use something called chunking. Think of it like this. If you hear "baby food is good" over and over, your brain might start to group baby food and is good as chunks. The researchers use the computer model called CIPAL, which is designed to do just this. It learns by creating these chunks of sounds that often appear together. CIPAL works by building a kind of layered memory. When it hears sounds, it tries to match them with the biggest, most familiar chunks it already knows. If it can't find a big chunk, it breaks it down into smaller ones. Over time, if it keeps hearing certain sounds together, it'll try to create a new, bigger chunk for that sequence. This is how it builds a hierarchy of chunks, from individual sounds all the way up to whole words or phrases. The more CIPAL uses a chunk, the faster it becomes to access it, kind of like how we get faster at recognizing words we know well. The key idea is that CIPAL doesn't have a built-in trochaic bias. It doesn't know what a trochaic or iambic pattern is. Instead, the researchers thought that if trochaic patterns are more efficient for processing English, then CIPAL would naturally start preferring them. There are a few ways CIPAL could show this preference. First, it might be more likely to learn trochaic words as single big chunks. Second, it might need fewer smaller chunks to represent a trochaic word. And third, it might process trochaic words faster because those chunks are more readily available in its memory. So, how did they test this? They trained CIPAL with lots and lots of child-directed speech from English speakers. They actually did this in 3 slightly different ways to see if specific stress cues were essential. One way was with no stress information at all, just the basic sounds. Another way included markers for stress syllables in every word. And a third way had stress markers only on the most important syllables within phrases. After training, they tested CIPAL with 24 words that have a trochaic stress pattern and 24 words with an iambic stress pattern. These words were chosen to be similar in how often they appeared in the language. The training data came from a huge collection of recordings of parents talking to their children. They converted all the speech into sound patterns. Then, they created these 3 different training versions of the data. The baseline version was just the sounds without any stress information to see if the raw sound patterns themselves would create a preference. The lexical, stresses version added explicit markers for stressed syllables in every single word. The phrasal stresses version was more realistic, marking stress only on content words within phrases. This table shows some of the words they used. You can see familiar words like daddy, pretty, pizza on the strong, weak side, and words like about, because around on the weak, strong side. The numbers show how often these words appeared in the training data. And here is what they found. Across all 3 training conditions, CIPAL showed a clear preference for the trochaic words. It was more likely to learn trochaic words as a single chunk. It needed fewer chunks to represent them, and it processed them faster. This graph visually shows the results. For example, the top panel shows that in all conditions, more strong, weak words were chunked as a single unit compared to weak, strong words. The middle panel shows fewer chunks were needed for strong, weak words, and the bottom panel shows they were processed faster. This is a really important finding. Even when there were no explicit stress markers, CIPAL still preferred trochaic words. This suggests that the basic sound patterns and how they're distributed in English naturally lead to this preference. It is like the structure of the language itself makes trochaic words easier to chunk and process. They also found that adding stress markers actually increased the strength of this preference, which makes sense because it is giving the model more clear information. But what about when babies hear words they've never heard before? Developmental studies show that kids still prefer the typical stress pattern even with new words. So in study 2, the researchers wanted to see if CIPAL would do the same. They trained CIPAL again, but this time they removed all the 48 test words from the training data. Then they presented these unfamiliar words just once at the very end of the training. And guess what? CIPAL still showed a trochaic bias. It learned more trochaic words as single chunks, needed fewer chunks to process them, and processed them faster. Interestingly, this bias was even stronger here than in study 1. The researchers think this is because by the end of the training, CIPAL had already built a really good understanding of English sounds and patterns, making it even better at chunking familiar subparts of these new words. This table gives a peek into why this might happen. It shows that the trochaic words, even when unfamiliar, tended to have more frequent smaller sound combinations or n-grams within them. For example, the trochaic word candy contains can, which is a very common word, CIPAL. Having already learned can as a chunk, could more easily build a chunk for candy. Now, here's a really clever twist. They wanted to see if this preference was just about English or if CIPAL could learn a different stress preference if the language's structure was different. They knew that languages like Hebrew have a dominant iambic stress pattern. So they created a simulated version of English where they reversed the sound order within each word. This way, words that were originally trochaic now had an iambic pattern, and vice versa. And the results were stunning. When trained with this reverse language, CIPAL developed an iambic bias. It learned more iambic words, used fewer chunks for them, and processed them faster. This is super important because it shows that CIPAL's preference isn't fixed to trochaic. It genuinely adapts to the statistical patterns of the input. So what does this all mean? The core takeaway is that the trochaic bias we see in babies learning English might not be an inborn preference for that specific sound pattern. Instead, it could be a natural consequence of how our brains, and this model's brain, learned to chunk information. The way English sounds are distributed, with more frequent trochaic patterns, makes it more efficient for CIPAL to create and use chunks for those words. This chunking process, driven by statistical learning, seems to be the engine behind the preference. This research builds on the idea that chunking is fundamental to how we learn language. It extends it to explain not just word discovery, but also how we pick up on specific linguistic features, like stress patterns. The researchers suggest that we don't necessarily need a template for stress, but rather that our learning mechanisms, by trying to efficiently process the input, naturally lead to these preferences. This is a really powerful idea. What looks like a language-specific bias might actually be a byproduct of a general learning strategy. If you are learning a language where iambic patterns are more common, your chunking mechanism would likely develop an iambic preference. It is all about what is most efficient for processing the language you are exposed to. Of course, like any study, there are things to consider. CIPAL is a model, and babies are complex beings. This model doesn't simulate language production, only comprehension. Future research could explore if this chunking idea also explains why babies produce certain sounds or omit others when they start talking. But for now, this research offers a compelling explanation for why babies learning English seem to have a built-in preference for that strong weak rhythm. It suggests that the very act of learning to understand language by breaking it down into manageable chunks shapes our perception of its natural flow. What do you think? Does this make sense to you? Let me know in the comments below. And if you found this interesting, give this video a thumbs up. Subscribe to RUBIN'S Mind Lab for more fascinating research breakdowns and hit that notification bell so you don't miss our next episode. Thanks for watching, and we'll see you next time.